I wanted to take a quick look at some things that have 2 terms instead of 3 terms because those are a little bit different. So let's say I had x squared plus 3x equals 0, right? Or I could have x squared plus 3 equals 0. So when you have 2 terms, a lot of times it's a good candidate for inverse operations, but only one of these 2 problems is a good candidate for inverse operations. So this second problem is a better candidate for inverse operations because it only has that x squared. So if I subtract 3 here, I get x squared equals -3, and then I would go to square root. Now, there isn't a square root of -3 in our real number system, so I would actually say that there's no real solution to this problem. But let's look at this other one. This one's a little bit more unique because it has x squared and then a 3x. So there's 2x terms. So I could kind of make this look like my 3 problem by adding a placeholder. So if I make this x squared plus 3x plus 0, that's really kind of now a 3-term one. And I could think about how could I factor this? Well, I'd be looking for things that multiply to 0 and then add to 3. So I can do that because if I did 0 and 3, that would work. If I did x plus 0 and x plus 3, that would give me x squared plus 3x. So the factored form of this is x plus 0 or x plus, times x plus 3. And really x plus 0 is just an x. So you can actually kind of think about it as like factoring out a greatest common factor as well. And then thinking about, okay, I've got something times something that equals 0. So either x equals 0 or x equals -3. So just something to know, a little bit different when we have 2 terms.